everyone, welcome back to Structure. Today we had to design circular OC water tank by using Graitec Advance Design. Now let's start. We had to active top view and draw a circle. Click first point, enter the radius. It 6 meter. Number of side, we take the number of side is 30. And after that we create another circle. Radius is 6.5 30 the same. we select we select this circle and we convert it to the wall by input the vector to the Z direction is 4 meter and the number is 1 twice there, and concrete we can change. We can import the concrete strength. Yes, okay. We select C 30 megapascal, and for the thickness take is 30 centimeter. And you can preview. After preview, you click on the C key and control middle mouse. Okay, apply. Now we have to convert the outer circle to the base. Now click on the T, convert line to the planar element. We have to keep the line, so we click on no. You see here, this is for the line. You can click and delete it if you don't want to use it anymore, and you can create substructure by press Ctrl S by press S key, and I call it wall. Another one I call it base. Okay, now select all wall and move it to the wall, and for the base we drag it to the base. Now you can click to display and to hide object. Okay, now we have to select all the wall, check number 3 is correct, thickness is correct, and for the concrete design we enable to design for the concrete. If you untick this, the element will be not designed for the OC structure, just for the analysis. And we check for the concrete cover. We take concrete cover to 4.5 centimeter, 4.5 centimeter, 4.5 and 4.5. And cloud exposure is we take it to 8h1. Okay, for the standard deviation of concrete cover is 1 centimeter. And we continue to for the switch, we active for the characteristic and frequency, and for the deflection we active calculate for the deflection, and for the punching we also active all the function. Okay, now it's correct. Now we have to check for the base. The concrete is 30 and the thickness we correct to the the same, the 30. Not the same, the top for the wall we use 30. For the base we use the 30, and concrete cover we use the same 4.5. You have to change it to 4.5. And glass exposure we use the same, and we also active for the service and check for the deflection. Now everything is complete from the link. We have to continue to assign support. For this tie support, we have to define soil spring or soil thickness, because our structure is on the ground, is on the soil, it's not on the solid element, so we cannot assign for the rigid. It's not a realistic, so we have to take the realistic support is elastic support. So for the elastic support, you have to define for the soil. Click on the manage menu and click on the use soil. Now this is for the default material, default soil. In Graitec, we have to add other soil. Okay, now I just add soon. You can add soon. This default name is soon, new soon, so you can add soil. Okay, now we have at the top layer is gravel. The thickness is 0.3. We add soil, and the next layer is sand compact with granular is 0.4, and we add the soil. We use the sand medium round. Okay, now we take the thickness is 3 meter. Okay, you see here, this is for the calculate all the active coefficient Ka. This one for the elasticity for the soil modulus. Okay, click OK. Now click on the base and come back with the home rigid, or you can click on the elastic linear, and after that you have to define for the vertical thickness. You can select for the import. You have to menu the view by calculating, and after that you type that view into this row. But in the case we have to calculate automatically, use the auto and click on the soil layer. The soil layer, we click on the new zone which has defined it, and click on OK. 3 again. Object, utility, home. Okay, rigid area. Sorry, we select with the wrong. Click the elastic area and auto define, and click on the new. Okay, click OK. Now we try again. By clicking on the elastic area and clicking on the auto define and select the zone. Just complete the input, click OK. You see here, this is for the value of the stiffness calculated automatically by software is 233388.50 kilonewton per meter per square meter. For now we create another new folder, ASIC support, and then move it to this folder, and you can view it in wireframe. And you click on your support. You see here, this is the automatic calculate based on the soil property. Now we have to seal the model. Or see actual le tank. Seal. Now we complete the model, assign support. We have to continue to assign load. Okay, by clicking on the load, you have to create for the load, and now we have to create for the light load. Okay, for the deload in the server or structure and the load, we can consider for the water and for the soils, and in the case we consider the soil is the deload and consider the water inside the tank is the light load. The outside the tank has a soil surrounding this structure. The structure is in the ground, so we have applied for both pressure of the soil and all the water. Now we start from the soil. Okay, now we click on the wall and right click, pressure on selection, and you have to select on soils, and you can import, as you can determine the pressure. It is for the internal, the direction is the internal to the internal. Click the internal, and the load case is the load, and the upper level is 4, and you can click from the previous one if you consider it the same, but this one for the base, and for the top layer you can use other soil layer. Okay, now we have to use other soil layer. You can click on it, delete it, and you can add another soil type for the pressure on the wall. The previous one we use for the base. Okay, for the base slab. Now I do the clay, and the thickness is 1 meter, and add other soil layer. Equals we select A2, and we add another layer. A3. Now the layer is total 6, so it can calculate the pressure on the wall. Just click OK. You see here, this is for the pressure direction to the internal wall, to the inside of wall. You click on the right click auto scale, and you can display about the loading and the reload. Show the intensity with the unit. We want show only for intensity. Okay, you see here, it is for intensity. You can correct with the touch size. Okay, you can change it. Now just take a look. This pressure calculated based on the soil property. This is for the soil pressure. You can change it, change name, but I don't want to change. I keep it. So we have to continue to the liquid. Select on this one, and you double click on the load, and select on the wall again, and right click, pressure on selection. Now you change from the soil to the liquid, and set it up direction, and the groundwater level is 4, and the pressure is the internal, the direction to the internal wall. Okay, and the liquid density, you can input density for the water is 1 ton per cubic meter. If you have another liquid density, you can put example for oil, for other material. You can put the density in here. Now just click on OK. You see here, this is for the pressure of the water on the wall, the direction to the outside. And we had to input for the base also. Click on base, the pressure on selection. Okay, now we don't want to show support. I want to click on support. Okay, click on base again, and pressure on selection. Okay, the direction is set, and the liquid density is 1 ton per cubic meter, and click on OK. You see here, for the base is not calculated automatically, so you can calculate it by on the value is 49.23. Okay, we keep it. Apply load on selection, minus set E 73.23. Click OK. But the pressure is not outside. Okay, delete. We have apply only for the inside. Inside. So so in the case you have to add another slab. Because the pressure is not in the edge, it's only for the internal wall. Now we have to create another slab. I just click on the base, is 1. Now we come back and correct our there. I turn all slot, and we have to correct our there. Home, top view. Okay, so the working plan, and we have to create another opening or opening. Okay, now let's start from here. 11.5 30 sorry, again 5.5 30. Okay, you see here, this is the line. Now we have to convert the line to the opening. Object utility opening. Now you can show for the full 3D view. Okay, now we have opening. Instead that we create another line to create opening. Okay, now let's start with this line and utility, and convert line to plan area. Okay, so you see here we have different for the base. Okay, now you can apply the pressure on the base. Okay, we show all load for the load, and this one for the light load. Okay, the light load we apply for this belly. Right click, load on selection. Okay, now we have to check. Okay, incorrect. Reload. Okay, incorrect. Now incorrect with our construct, and we check for the load case. The load for the soil apply on the wall, and line load for the pressure of the water on the bottom slab is correct. Another one is for the pressure on the wall. So we have to move this load, or click C key, select at the bottom and drag it to the line load above. Okay, so we have to check again, double click on line load, turn off and turn on. Okay, no, so we have to delete it. Now we have to check about the load. It has line load. Okay, for the pressure on the wall and for the pressure on the bottom is correct, and for the deload for the soil pressure is correct, and you have to seal it. Now continue to load combination property. You can define the simplified combination. So you can load from CBN. Now I just click on simplify, and you can check for the equilibrium analysis combination, and a category view for the storage. And snow we do not apply, wind we do not apply. Okay, now you can generate. Okay, you see here for the concrete is 1.5 deload, and other case is 1.35 for the deload, and this one for the light load. But we also has another case. Okay, this one for the deload when the soil apply only without the internal pressure of the water. This one is correct, and this one when we complete for the construction and you have another liquid inside, so the combination will be work. So our combination is complete and right with our concept right now. Okay, now let's click on OK, and click on envelope, create family envelope. Click on it, property. You want to envelope on the first, on the linear element, mark and mint. Okay, okay, we apply for all. Okay, apply, close. Now let's start to analysis, and we click on OC design, click OK. Now you see here, null pivot too small. Okay, click OK. Now our model is error, you have to check about model. I turn off or load, and turn on for the structure, and click for the base. You have to input for the car bar. Now I have to input it around fonts 5,000. Sorry, 5,000 and 5,000. Okay, now let's start again. Okay, now you see here the warning is plate and throw 42. Cracking limit is it the bottom face in load case 100 the plate and throw 32. You can come back to home and select my criteria and select on plate select on the type model plate, and you can identify for the 32. Okay, you see here is on the base 32. You see here the identifier is 32. So this one we have to check about the concrete again. We use this concrete, and to make sure the concrete staying is correct. Okay, now we have to check to turn a spot, check again is correct or not. Okay, it's correct, and the cover is also correct. Another plate, now we have to change it to 4.5, 4.5, 4.5, 4.5, and the cloud exposure it is 1. And we also calculate for the deflection, and for the survey we also active for the characteristic and frequency. We also calculate for the punching. Okay, and for the thickness we 30. Okay, so this one 30 and this one 30 is correct. And now let's see again. Instead that we had to create new analysis again on OC. You see here in command line no other error. Okay, now design is complete without any error. So we had to check on about force. You can check force, and you check for the envelope for maximum and for the slab. Okay, in each you can see here for the maximum moment about in each for the local axis. You can display for local axis to check where is the each direction. You can display, click on the family, geometry, model, is the plate, and show the local axis. Okay, see here is it for the local axis. Order base slab. You see here the local axis in this direction. So in this case you can change it. Now I turn on the wall, and you can change, click on tool, and you can change the local axis. Okay, you can view at the top. This local axis is similar with the global axis, so easy to check. Okay, now come back for the analysis. But you can run it again. Okay, now we complete analysis without error. We have to save, and now you can view for the other element. Click on structure. Okay, you see here for the local axis display, and now we have to display for the force and for the maximum envelope, and so for the ME8 you see here the maximum moment is 14.24 in this location, and by maximum is around 8.89. so this view is this mode you can optimize your signal again. And for the other force you can check for the axial force in each direction. And you can check for the force. Now let's start to the reinforcement, and for the reinforcement at the direction in bottom you can check this one use the minimum reinforcement, and for the bottom in y direction is the same, and for the reinforcement in each direction at the top and in y at the top is the same. This use the minimum reinforcement. You can check for the maximum view. Okay, now we have to come back and check our depth again to check to make sure our model is running without any error. Okay, now I check for the reload. Okay, this is for the pressure or the soil pressure. This one for the water pressure. Okay, now you just take a calculation to verify the density of water is 10, so you have to multiply with 4. It's around 39.26, correct? If you it's more because it's balance between the internal pressure and the external pressure when you apply for the water and for the internal pressure of the soil. So the control design is for the dead load. You can check dead load is applied for the soil pressure on the wall. the soil pressure is around 20.33 kilonewton per square meter. So in the case, you can check for the soil pressure. This one is correct. Now we have to optimize about our thickness. Come back and turn off loading. Okay. Now I want to 25. Okay, 25. Correct. And we don't want to use line again, so we have to delete it. And this signal we take it 25 or 20. Okay. Okay, now we have to calculate it again. And you have to check about combo is correct or not. For the concrete, for the factor for the load, the factor for the load and line loads is correct. Okay, everything is correct. Now you have complete analysis design without error, and you can come back to check for the displacement. Now we have to check for the displacement. You see here the maximum displacement is around 0.08 centimeter. Okay, is suitable for the view. And come back again about the force maximum and MEH is the same, and bye. See here in each direction at the bottom need around 308 millimeter per square meter. It B is the same, it T is the same, it B is the same. This need the minimum reinforcement. You can check for the stress at the top. very small. And this one for the tension. See here for the compression and for the tension.